Hey, happy Friday. It's Mr. Morrow here. Unfortunately, I'm at a meeting today, so you're going to learn about analyzing loans through this awesome video. Oh, and hey, look, it's Mr. Brown. Say hi. All right, let's get started. Okay, guys, first off, we're going to look at a single payment loan. This is a kind of an awkward situation, but we'll just try it out. Sean borrows $10,000. Right there, $10,000. I kind of crossed it out. At a fixed rate of 5% compounded monthly. He waits 5 years. He does nothing to pay this off. And we now ask, how much will he need to repay at the end of the loan? Oh boy. Okay. And we'll also ask a second question after that. Well, let's see. We had a formula that we used before, right? A equals P times 1 plus I to the N. Okay? In fact, I can use this same formula all over again. Okay? I'm really asking how much will his single payment be? So I'm asking, what is A? I don't know what the amount is that he's going to owe at the end. I know he starts off by owing $10,000 for the principal. The rate of interest, well, we got to be careful about that. It's 5% compounded monthly. So 0.05 over 12. That's the worst looking 5 ever. Close that. And then N is the number of compound periods. Well, we've got 5 years and it's monthly. So quick math in my head, 5 times 12 gives me 60. Okay, let's type all that in. All right, I typed it all in and I get a final answer of $12,833.59 after rounding. Okay, so that's how much he's going to have to pay. There's a second question though, and that is how much interest did he pay? Okay, so how much interest did he pay? Well, I mean, we can think about this pretty quickly. He borrowed $10,000 and he paid back $12,800. Well, whatever the difference is, that's the interest, right? So we can calculate out the difference, and if I do that, I believe, because it's a nice round number, I get $2,833.59 for interest costs. All right. But that was a little strange of Sean to pay that all off at a single go. Normally, you would kind of try to pay off the loan a little bit at a time so that it doesn't accumulate all that compound interest, right? That was a bad strategy, Sean. So instead, we'll try to make a regular payment. And for this, we're going to use our TVM solver. So I'd like you to read this question right now, pause the video when I say to, and fill in the TVM solver and see how it goes. So pause now. Okay, welcome back from pausing. So let's see. We've got an interest rate of 5%. Write a 5 in for I. We've got a present value of $10,000 owing. We could call this a positive $10,000 because it's money that came in to Sean. And at the end, he's going to have nothing owing after having made all these payments. And it's really the payment that we don't know. So we'll have to solve for that. What else do we know? Well, N, let's see, there are 5 years, 12 payments per year, so 12 times 5, again, that gives me 60. Payments per year, we already just mentioned that, that's 12, and so compounds per year, we also see that's 12, and again, we always set this to N. Type all this in, and hopefully you get a final payment of $188.71. Okay, so that's how much he's going to pay each month. We have a second question again that's the exact same question. How much interest did he pay? Well, this is a little bit harder to figure out, but it's actually not too bad. If he paid $188.71 every time, and he made 60 of these payments, we can ask how much did he pay in total. So we'll say the payment total. I gotta get a new pen. This one's so old. Payment total, we had $188.71 times 60 payments. Oh man, I should have typed this in before. 60 times 188.71. He paid $11,322.60. And so therefore the interest, well, if he paid $11,000 and change and he borrowed $10,000 in the first place, then that makes his interest 10,000 minus, or 11,322 minus 10,000. I believe I get 1,322.60. Let's do some thinking here. The interest is dramatically lower if you make regular payments. The interest cost for the regular payment was $13.22. The interest cost for the lump sum was $28.33. Both of those with some pennies added in. Look at the difference. That's an enormous difference in savings. So regular payments are way better for the borrower. That's what it says right here. It is better for the borrower to make regular payments instead of a final lump sum. That takes advantage of the fact that your interest isn't accumulating over time. It's not compounding. But why would the lender agree to such a deal? Why wouldn't the lender just say, pay me back whenever? Well, there's two reasons. First, the lender is going to want the cash to come in. So the lender wants money flowing in, so he needs cash flows. The second reason is actually a trust level. If I lend money to someone for 25 years and I say, don't worry about showing up and paying me back for 25 years, well, how do I track them? How do I know what they've been doing? So if I get someone instead to make regular payments, I can track them a lot easier, and I know that they're making their payments, so I know that they're out there and they're trustworthy. Okay, it's a good way of building a trusting relationship. Okay, and here's the last thing here for us is mortgages. Mortgages, this is money that you borrow from the bank to buy a house. And the house is called collateral. That's one of those fancy words you can look up in the back of the book. Collateral is just the stuff that they take if you don't pay. So the house is collateral in a mortgage, and if you don't pay it, they can take your house away. Kind of sucks. Now, by Canadian law, this is actually in the law, compounds must be semi-annual. This is to avoid the fact that banks would lend people hundreds of thousands of dollars and say, oh, it's only 6%. And then in the fine print, it would be compounded daily or something like that. So by law, every one of these is semi-annual in Canada, but you often make monthly or bi-weekly payments. Bum, bum, bum. So we'll see on page 87, example 4, that there is a problem here with monthly and bi-weekly payments versus compounds that are semi-annual, but it can be fixed so easily. And here's the fix. First off, your compounds per year, well, that's 2. And then your payments per year, well, it depends on the situation, but let's say it was monthly, you'd have 12 per year, or bi-weekly, you'd have 26 per year, or something like that. Now notice when you go to try and edit these into your TVM solver, if you change P over Y, it actually changes both. So you have to go and type in payments per year first, and then compounds per year second. Second thing that you have to be really super careful about is N. N is not the number of compounds, it's the number of payments. This is vital. So, if you're making payments every month for 25 years, in that case, payments would be 12 times 25. Doesn't matter that you're compounding it twice per year. What matters is that N is the number of payments. Anyway, take a look at example 4 on page 87 and see if you could type into your TVM solver and match the result there. Finally, while you're looking at example 4, I'll tell you what the homework is. Here we go. First off, I want you to read the summary on page 91, and that will kind of summarize what we've just done. And then on page 92, there are questions to be done, and be careful about number 11. Okay? Have fun, guys. We'll see you on Monday.